So we are still in section 5.1. We are discussing how to solve these systems of linear equations. And we looked at substitution already, and now we're going to look at another method to solve a system, and it's called the addition method. Some books call it the elimination method, so you might have been through that method before. It's the same thing as this addition method. And so let's fill in the blanks. So it says, if necessary, rewrite both equations in this form. So basically, you're rewriting them both to look all the x's together, all the y's together, the equal signs, and then the constant together. If necessary, you have to multiply either equation or sometimes both equations by an appropriate non-zero number so that the sum of the x coefficients or the sum of the y coefficients is 0. So what you are trying to do here in step 2 is to create opposite coefficients. Then you want to add the equations in step 2 together. The sum is an equation in one variable, and then you will solve the equation in one variable, and then you do the back substitution again to find the what you found in step 4 to find the other variable that remains. And then lastly, just like before, you want to check the solution and you want to make sure it works into both of the originals. So these are my steps, but we're going to take each of these steps, we're going to write them down here, we see that here, and we're going to do the same this with this system. We're going to do the addition method with this system. So when I take a look at this system and I see it and I compare it to the one I had earlier, I want to make a choice. Do I want to use substitution or do I want to use addition? Now this one would be more ideal for the addition method because I don't have a coefficient of 1 or -1 on any of my variables. So if I do the substitution method, I'm going to probably be working with fractions. But you could do either method here. Now, step 1 was to rewrite both equations in this form. They are already in this form. What do I mean by that? All I mean, the form of ax plus by is equal to c. Everything is kind of lined up. I have them all lined up already. If for example, the second equation was written like this is the same as the second equation. It's just the two x's moved over. You'd want to make sure they're moved over so that all the x's are lined up, the y's are lined up, the equals are lined up, and the constants are lined up. So since the equations are both already in that form, we don't have to do anything there. All right, so now we're going to move on to step 2. Well, step 2 says, if necessary, you want to multiply either equation or both by a number to create those opposite coefficients. So there are different ways you can do step 2. So let me show you one way. The easiest way, we want to create opposite coefficients. So what I could do here is I could take, if I want to make an opposite coefficient on the x's, I can multiply this equation here by -2. And when I say multiply this second equation by -2, I don't mean just this first term. I mean each of these terms. So I would multiply each of those by -2, and that would create opposite coefficients on the x term. So that would be one way to do it. There are other ways to do it also. Let's say if I look at this, what if I want to create opposite coefficients on the y's? Well, you can multiply either one or both equations by a number. Here I could multiply this equation by 3. That would give me 15y. And if I multiply this equation by 5, it would give me -15y. And I would have opposite coefficients. So there's multiple ways you can do step 2. You have to choose which way you want to do it. I would stick with the easier one where you only have to do one of the equations, but you could do it either way. It will work out in the end. So let's do the multiplication to make the opposite coefficients on the x. So I don't touch the first equation. The second equation, when I multiply it by -2, everything will be multiplied by -2. That will create a negative 4x, a positive 6y, and then negative 14 at the end. And now I have opposite coefficients. So that will lead me to step 3, where I will take the two equations I have now. So let me rewrite them here. And because I have opposite coefficients, I will add the two equations together, and one of those variables will drop out. So I'm going to add the two equations together, and you will notice 4x minus 4x will give me 0x. Here I'll have 11y. 5 plus 6 is 11y. 3 minus 14 is negative 11. And now I have dropped out one of those variables. So now I'm left with this, and I can solve this equation that results. Divide both sides by 11, and I end up with my answer for y, which is -1. Remember, you don't stop here. This is only part of it. So now I have to take and go to step 5, which said back substitute it to find the value for the other variable. So 4x plus 5y is equal to 3. And so now I found what y is equal to. So I'm going to substitute it in here, and I can do this into either of the original equations. And I will solve now for x. So I need to get x by itself, so let's add 5 to both sides. And I end up with 4x is equal to 8. And then I don't have x by itself until I divide both sides by 4. The proposed solution here will be x equals 2 and y equals -1. So writing it as an ordered pair. Step 6 is to check it. So go back. I'm going to rewrite both originals. Here's the first one. Here's the second one. And I'm going to check. So I'm going to substitute in the proposed solution into each one and make sure that it works in both. So I ended up with x is equal to 2. So plugging in 2 for the x, and I ended up with y is equal to -1. And now let's check. Does the two sides, are they equal? 8 minus 5, does that equal 3? Yes. So it works here. Does 4 plus 3 equal 7? Yes. 7 is equal to 7. It works here. So since it's true for both, then the proposed solution is the ordered pair 2, -1. Now, in the two problems that we've done for 5.1, we have gotten one solution. If you get one solution, exactly one ordered pair solution, that means you've gotten one solution. And what that will look like on the graph means the two lines will intersect at that point. So, for example, if this first graph here is an example of what it would look like if I had a linear system that had one solution. If there is no solution, then what happens is you end up with lines that never intersect. Those are called parallel lines. So if you end up with no solution, you will have on the graph parallel lines. And then the other possibility is that you have infinite many solutions, and that means the two lines are identical. And you might not see it originally, but when you solve for it, you're going to see, meaning the two lines are identical, and you can see it in this third graph, they're lying on top of each other. So if I was to take, let's take the last problem we just did, and let's graph it. And let's see what it looks like graphically. So this is called Desmos.com, DESMOS.com. and they have a graphing calculator that you could use when doing your homework. You can't use this on the exams, but you can use it to reference for your homework. You can also use the calculator, the TI-8384, and that is one that you can use when taking exams. So let's take the two equations that we were given, and I'm going to type them in here. So on the left-hand side, I just simply type out 4x plus 5y equals 3, and I will show you what I write in there. And then I'm going to put also the second equation, which was 2x minus 3y is equal to 7. So, and let me see here, hold on. So now I've shown you the left side, what I'm writing on the left side. I put the two equations. The nice thing about Desmos is that you don't have to solve it for y, but in the calculator you have to solve for y to put it in the calculator. And you're going to see that the point where they intersect was the point that we found as the solution. So when I put my mouse here, I can see 2, -1 is this point of intersection, and that was the solution to that system. So that shows you an example of this first row here. One solution will show you, will give you that the intersection point will be that solution. Now let's take a look at a system that has no solution and what happens. So with this system, let's say that we wanted to do the addition method. Well, when I look at this and I want to do the addition method, if I want to get rid of the x's, I would multiply this top equation by 2. When I multiply the top equation by 2, I would end up with this. And now when I go to add them together, what's going to happen is that everything eliminates on this side. I end up with 0x, 0y, I get 0 is equal to 15. Is 0 equal to 15? No. This is a false statement. 0 cannot be 15. So if you get a false statement, then you're going to say there's no solution. The false statement, 0 equals 15, indicates that the system is inconsistent and has no solution. If we were to graph these, we would see that they are parallel lines. They would never intersect. The solution set here, when you end up with this, it's the empty set, and that is written like this. So it's the empty set, and you indicate it with this circle with a slash through it. So it's not a 0, but it's a circle with a slash, and that tells the reader that you have an empty set. Now, what about if you were to graph it, what does it look like? It looks like this. So they drew it over here for you. The lines, there, it's the empty set. You see that notation here. The lines will be parallel, and there will be no point of intersection. Now let's take the next type. Here we have this one, and I'd like you to try to solve this one. And I'd like you to try to solve this one using substitution. So pause the video, try this one, and then come back and check how I did it. So you can use either method to find this. I'm going to use substitution, but you can use addition. With substitution, this is how I did it. I substituted, this was already solved for x, substituted in there, and then when I simplify it, I end up with a true statement. So different than the last time, because this one is true. And so if that is the case, then there are infinitely many solutions. And that means that the two lines were the same. And the lines are, if you were to graph them, they would be the same line. They lay on top of each other. And so how do you write that? How do you express that? Well, what they do is they use this set builder notation. And they just take the equation of the line and put it in here. And so you say, you put the braces, and then you put the ordered pair, whatever variables. In this case, we're using x and y. And you put this vertical line that means such that. and then you put the simplified equation. So you could write it either way with either equation.